DC drive is the functional circuitry that can be employed to precisely control a DC motor. The drive operation allows the application of varying DC input levels so that the motor runs efficiently at different speeds. A DC drive circuit is composed of three main components: an operator controller, a drive controller, and a DC motor. One of the functions an operator controller provides is a method for altering the speed of the motor. The drive controller will regulate the input by means of either a phase control device or a pulse width modulator. And the DC motor can be an electrical device that needs to be adjusted to perform at various speeds. Let's look at the phase control method in a bit more detail. Phase control works by modulating a gated diode-like device, such as a silicon-controlled rectifier or SCR, into and out of conduction at a predetermined phase of a rectified AC half wave. This diagram depicts an AC sinusoidal wave being altered by a full-wave rectifier to produce partial half waves. The partial half-wave output produced is reduced based on when the firing device is activated. Adjusting the speed at the operator controller will determine when the SCR is activated and at what point in the half-wave cycle the wave is turned on or allowed to pass through. The area of the waveform will determine the amount of voltage delivered to the motor. Pulse width modulation, or PWM, is a method that uses digital signals to control power applications. In this example, a PWM uses a full-wave rectifier to convert an AC input voltage into a DC output level of 300 volts. A control circuit operating a DC switch turns the DC output on and off. This controller device can be an SCR or a powerful transistor. The on and off cycling of the controller circuit produces a repeating 300-volt square wave with a fixed frequency and width, as illustrated by this typical output displayed on an oscilloscope. One of the parameters of a square wave is the duty cycle. This is derived by dividing the time on duration or width, t sub 0, by the duration of the wave period, t. Thus, if the period is 2 milliseconds and the time on duration is 1 millisecond, then the duty cycle is 0.5. The voltage reduction will be 0.5 times 100% or 50%. Multiplying the duty cycle times the input voltage will give you the voltage output. In this example, a 300-volt input will be modulated by 50%, so the final voltage delivered to the load or motor is 150 volts. Thus, controlling the speed of a motor can be achieved by modulating the square signal waveform.